Log on, tune in, find out. Another good idea from Cambridge.
Okay, so welcome back then to this afternoon's session, and we're very pleased to have Dr. Francis Collins with us, who, as you know, is head of the Human Genome Project and has been involved in the whole of the genomic projects now. We haven't called them plural projects for many years. And recently has written this book, The Language of God, which we have in the bookstall and which has been selling very well, and I hope he'll take the opportunity to buy this book while he's still with us. And having looked at genomics early on in the afternoon, we're now going to switch a little bit and look much more at the ethical challenges which arise out of the genomics era. So thank you very much, Dr. Collins.
Thank you. What I'm going to try to go through in the course of the next hour, and it might be a little less this time as opposed to what it was before, which is a little more, is an effort to try to lay out some of the bioethical challenges that have arisen out of these advances in understanding the human genome, our own instruction book. I should say, and I probably should have said at the beginning of the other lecture, that I am now speaking to you as a private citizen and not as a representative of the United States government. Because sometimes people are curious about that. Since I am a federal employee, my boss's boss's boss is the president, so I need to be clear that I am not at the present time representing the views of any elected or unelected officials. And instead, I'm talking about this from my own perspective. I think it's fair to say, and perhaps you will see as we go through some of these dilemmas, that there are echoes of the bioethical challenges that we now face that go back quite some time. I don't think it's actually the case that the study of the human genome per se has actually ushered in any brand new considerations that weren't somewhere in somebody's thinking or projecting about the future. What the Genome Project and all of its other associated efforts has done is to accelerate the pace rather dramatically of some of these discoveries, so that dilemmas that people might have thought we could wait 100 years to worry about are now closer upon us. And that means I think we have more of an obligation to respond. And response comes in lots of different forms. I will particularly try to outline for you areas where there clearly is a challenge, where research needs to be done or is being done. But in my view, in many ways, the hardest part of this is once you have debated and deliberated and come up with some options, is to actually implement them. Because it's one thing to arrive at an academic conclusion that you think is solidly backed up by evidence. It's another thing to try to get the political process to take action. And in my own experience, that last step can be both very slow and very frustrating because lots of other things come to bear at that point. And I'll give you at least one example of that circumstance. So in going through this, I decided to focus specifically on issues that relate to the human genome per se. And so I've not included in this presentation a discussion about stem cells, but if we want to talk about that in the discussion, I'm happy to do so. There is some discussion about that in the book, The Language of God, which, by the way, has an appendix at the back on these bioethical issues. I decided to put that in the appendix because I thought it might actually get in the way of people who weren't that interested in those issues, but some people would want to have a chance to dig into them, so that's why it's back there at the back. So that's what you're in for, and again, I'm amazed that people are tolerant of putting up with a total of 3 hours of me, and I appreciate your willingness to come back and do that. So, as mentioned, we had this remarkable 50-year experience going from the double helix structure to the entire DNA sequence of the human genome, and I don't think that we necessarily were fully prepared for dealing with that kind of accelerated pace. But I am proud to say that the Human Genome Project did take as one of its mandates from the very beginning of the effort in 1990 a determination to focus some of the resources of the project on studying these ethical, legal, and social issues. And that is a new experiment. I'm not aware of another example historically where a scientific enterprise of this sort decided to embrace the need for ethical, legal, and social issue research along with the project. It more traditionally has been, let's do the science and worry about it later. This came about in a very odd way. When the Genome Project was first being announced in the United States, the person doing the announcing was my predecessor, Jim Watson, who was the first director of the effort. And Jim was giving a press conference about what the initial plans for the project might be. And a couple of the people in the press were badgering him about whether we had really prepared ourselves for all the ethical consequences of what this project might mean. And Jim, pretty much on the spur of the moment, without, I think, having thought about it, and certainly without having talked to any of his staff about it, basically announced, well, we all have a program on the ethical, legal, and social issues, and we'll spend a certain percentage of the budget on it. And that stopped the argument right there. If you talk to Watson about this, and I talk to Watson a lot, and it's always interesting, he would tell you that basically this was a way of shutting up all those people who are worried about these things. Because in Watson's view, there really aren't a whole lot of ethical dilemmas, that basically this is a way of finding out what's going on in DNA and using it in whatever way you darn well please, including having major effects on future generations. So the program, I guess, therefore, has a slightly interesting history in that it was, in a certain way, put forward in a defensive posture. But I think very quickly, others identified this as a real opportunity not to be reactive, but to be proactive. And I think that has actually been a, so far, interesting and I would even say successful experiment, but it's still an experiment in progress. Of course, one of the first things the ELSI, and that's the word I'm going to use, ethical, legal, and social implications, ELSI. First thing the ELSI investigators and researchers had to start to think about is what are the real problems, as opposed to what are the really goofy ideas out there that people are spending time worrying about that are scientifically just not going to happen. And you don't have to look very far to see that there are a lot of goofy ideas out there. You find all bunches of cartoons like this in the course of the project of the Human Genome, suggesting that this is really what it was all about. So instead, I think the way this played forward with the project was to try to identify in a really thoughtful way and prioritize what were the most critical issues. And as a result of this, having developed that set of priorities and offering resources, this became, and still is, the largest financial investment in bioethics research that the world has ever seen. My institute, the Genome Institute, at NIH alone spends $20 million a year on supporting research in bioethics as it relates to the genome, which is a very large investment for this particular field. And that has resulted in the recruitment of dozens of researchers from a variety of different disciplines, including social science, including law, including ethics, and including theology, to try to put their best efforts into wrestling with some of these problems and making recommendations about what we should do about them. So I thought, in trying to put this forward, although I'm not going to show you any TV clips in this talk like I did in the last one, I would adopt a particular perspective of a different TV late-night host in the United States, one David Letterman. And if you ever watch Letterman, you will know that one part of that is to have a top 10 list. So I'm going to have the top 10 list of ELSI problems and challenges, and you can decide what I've left out when we get there. And actually, I didn't try to make it turn out to be 10. I just realized this morning it was 10. So, and of course, every preacher will tell you that 3 is the right number and 10 is way too many if you're trying to make points to people. But hopefully, this is a very sophisticated audience and you can handle it. So number 10, and these are in no particular order. Don't assume because this is number 10 that it's the least important. It might be the most important. It's certainly the one which is closest to my heart in terms of trying to get an actual solution in a legislative way. You saw in the presentation I gave earlier that we're just rocketing forward in the ability to identify genetic variations associated with disease, and that there are companies out there marketing their wares to tell you whether you're at risk or not. And if I set up a little booth at dinner time and asked you to scrape your cheek, and I would call you in a couple of weeks and tell you what your risks are after I checked out your DNA, some of you, I suspect, would at least be moderately interested in that. But of course, there is a negative side to this. It depends on what country you live in, how negative that might be. Suppose that information gets used against you. If you're at risk for a cancer, or you're at risk for Alzheimer's disease, does that mean your employer kind of decides, not such a good investment after all, maybe better not put the company in that person's hands? Or in the US, the big anxiety is health insurance, since health insurance is not universal. And you can, in fact, lose your health insurance in the United States if your insurer decides that you're not a good risk anymore. It happens quite regularly. And so information that you might wish to have for your own medical benefits to practice better individualized preventive medicine might actually result in you not being able to practice any preventive medicine because you don't have any health coverage. So this is a very serious issue, and it was identified early on as perhaps the area that was most urgently in need, not just of good research, but actually of policy activities. Because if we don't take action on this, as the cartoon will point out here, we will all be on the receiving end of this particular piece of hardware. Again, let's not make a mistake here. This is not about a few other people. This is about all of us. I didn't say this earlier, and I hope I don't ruin your afternoon, but we all have dozens of DNA changes, variants that place us at risk for something. There are no perfect DNA specimens. If you start into a circumstance where that information can be used to discriminate, then we all should be worried about it because none of us will be potentially free of that risk. Now, people have looked carefully to see what does the public think about this. Here's a paper from the New England Journal of Medicine just from a couple of months ago. And interestingly, again, this is the U.S., people in general are okay with their physicians knowing about this, although not entirely, but mostly. And even with researchers, a little less confidence, but the majority can see why this would be valuable. But with health insurance or your employer, people are not at all trusting that that's going to have a good outcome. So we have this kind of public concern, which is clearly the majority of the public. We have ethical analysis, which says this kind of genetic discrimination probably falls in the same category as discrimination on the basis of skin color. You don't get to pick your DNA sequence. It shouldn't be used against you in something as important as access to health insurance or the ability to conduct a job for which you're otherwise well qualified. So this is a matter of equity, it's a matter of justice, and basically there has been a rather unanimous conclusion now for about 14 years that this is something that ought to simply be outlawed, this kind of discrimination, by effective federal legislation. Well, we're not there yet. It's been 14 years. After many, many opportunities to try to get this case in front of the Congress, again, I'm talking about this in the U.S. because it's the place I'm most familiar in, and in this particular instance have spent countless hours on Capitol Hill trying to argue for the need for this. And I thought, when this bill was introduced and subsequently passed the United States Senate unanimously, that we were probably on a roll. That was 5 years ago. And in this particular instance, although it had passed the Senate unanimously, the House never took it up. So 2 years later in the 109th Congress, it again got introduced, again passed the Senate unanimously, got a number this time in the House, but no hearings were held, no votes were taken, and it died at the end of the 109th Congress. We are now in the 110th Congress. Senate 358 was introduced, as was now this time H.R. 493. And again, a great boost given this past year on April 25th, which happens to be DNA Day because that's the day in 1953 when the Watson and Crick paper was published. The House of Representatives voted 423 to pass this bill. And the Senate's already passed it twice, right? So this is done, right? No, no, no. Now that it looks like it's really happening, the forces that don't want it to happen are coming out of the woodwork. And in that instance, in the U.S., it's particularly the employer community, represented by the Chamber of Commerce, and the health insurance companies, who just don't want their hands tied. And the idea that anybody would tell them they can't do what they want to is something that they will reject. And they have enough clout to be able to essentially have put this on ice in the Senate, where it has languished now for the past 3 months. And if it does not get taken up within about the next month or so, and then we're going to get into election year politics in the U.S. if we're not already there, and it may be unlikely that anything will happen for a substantial period of time. So I tell this as a tale that's rather sobering. If you think that ethical dilemmas require good research to lead to substantive conclusions upon which broad consensus can be reached, and then it'll just happen, don't count on that. The then it will just happen doesn't seem to be so easy. In fact, I've been called for many hearings on this particular issue, probably at least a dozen, in front of either the Senate or the House. And invariably, the first question that I get asked by the staffer who's organizing the hearing is, so who are the victims that you can bring with you to this hearing? We need victims. Well, I can find some, because there are people who've been discriminated against. But do you hear what that says? That says, we don't take legislative action until people have been injured. The idea of doing something in a thoughtful, proactive, preventive way is just completely foreign to at least our legislative system in the U.S., and I suspect we're not all that different than other political systems. So this is a wake-up call for anybody who would feel a sense of confidence that if we could just identify the issues, then they would get taken care of. It seems you first have to get millions of people to have something bad happen to them. Then you get a big stir of emotion, it's a crisis, and oftentimes a bad bill then gets passed. It's sort of thrown together in a hurry. Not a pretty system. But again, we hope for the best. I guess it was Churchill who said, you can always count on the Americans to do the right thing after they've exhausted every other possibility. Let's hope that's true in this case, because we're getting pretty close to exhausting the other possibilities. Okay, number 9. This is an issue which, for me as a researcher, is now extremely hot. And you wouldn't think, after all these years of doing human subjects research, that it would be difficult to figure out how to find a balance between protecting people against harms and in making sure that you're inspiring lots of benefits for the public. But here we are in a circumstance where large amounts of genetic information can be collected on individuals. And for that to be maximally beneficial for the research community, it ought to be accessible to qualified researchers so that they can have a look at it and look at these very large data sets, like the ones I talked about with regard to genetics of common disease, and be able to make sense of them. The idea of having that data hoarded by 1 or 2 investigators is probably not in the best interest of the public. Yet, as soon as you begin to distribute this data, even if it has all the personal identifiers stripped off of it, even if it doesn't say, this is Edna Jones's record, it's got Edna Jones's genotypes in there, and those are unique to Edna Jones. Once you go past a very short list of genetic variants, there's nobody else on the planet, unless Edna has an identical twin, that is going to have that particular collection of genetic information. And the problem is, as more and more of these databases begin to appear, from health records, from law enforcement, from God knows where, it may be possible, if Edna's information is up on the web, for somebody to make a match. Not on her name or her social security number, but on her genotypes. And if that database that you've generated for research not only has some of her genotypes, but also some of her medical information, like she used to be addicted to heroin, then she might end up being injured in a major way by having some privacy invasion. So how do we deal with this? In the U.S., we have this big problem right now that people tend to have this mindset that information is either identifiable, that is to say, you can tell who that is, or it's not, in which case you don't have to worry about it. And anything that has some genetic information can't really be considered non-identifiable anymore because it is unique to the person, even if, in the classic sense of all those personal identifiers like address and telephone number, those aren't there. And so figuring out how to handle this in an ethical way, remembering the ethical mandate is both to protect privacy and confidentiality, but also to advance research, because that's a public benefit, has not been trivial. If you want to read more about that, I just wrote an essay with a very thoughtful public policy ethicist, Bill Lawrence, who lives in Geneva, about this issue, which came out in Science a couple of months ago, about identifiability and the ways in which this might be dealt. This has generated a lot of responses, mostly positive, but not everybody agrees on this. So for researchers, this is a big deal. How do we do this balance? And we're going to have to continue to revisit that as the science changes. What about patenting? This is a way to get a lot of emotions stirred, and I think it's interesting when you get into a discussion about patenting in DNA, people often quickly move into a sort of moral argument zone. I'm not sure that's the way to make much progress on this, because I really think patenting is a legal construct. It's not a moral construct. Why do we have patents in the first place? Patents, believe it or not, were not actually invented to help inventors get rich. The point of patents was to provide a limited monopoly to somebody who had discovered something that would require an investment to develop it into a product that the public could benefit from. And if you didn't allow that limited monopoly, then the inventor would have no real incentive to put what might be a very substantial amount of money into getting that invention turned into a product. And then the public wouldn't have the product. So the contract that was sort of put together legislatively was to say, okay, you get this period of protected time where you have basically the ability to scare off any competitors by your patent. But in return for that, you're expected to take that opportunity and develop something the public could use. So I think the real question when you talk about patents and the genome is, do they fit that model? Are you actually using the system in a way that provides public benefit? Or are you using the system in a way that it runs counter to that? And it depends very much on the application. Many interesting and amusing jokes about this too. And certainly for the last 15 years or so, the idea of patenting genes has been a pretty hot one. And I think many people intrinsically, at some sort of gut level, find it very offensive, the idea that something that's part of our own biology, a human gene, could actually be patented and claimed by somebody else in an ownership sort of way. Actually, that's probably not a correct interpretation. What gets patented in a gene patent is not the gene as it occurs in nature. It's the gene as it has been sliced and diced and put into some recombinant DNA vector and sequenced and maybe grown in a bacterial form. So you could say it's not exactly a natural product. It's very much derived from that. So what's the right answer here? Well, we're still debating that. And I think, frankly, we went through a very bad time in the 1990s where there was a real gold rush to patent all kinds of human genes without knowing what they did. And a lot of this was done by companies that were skimming off the cream by sequencing not the entire genome, but the bits that are actually expressed as RNA, which presumably are the parts that are going to code for protein. And the Patent Office in the 1990s in the US, and it sort of drove the rest of the world to, in most instances, to do the same thing, was willing to grant a patent for somebody who had derived such a sequence, even without having an idea about what it did. Now think about that. Is that going to benefit the public? Basically says that person now has the right to control downstream research on that gene, even though they don't currently know what it does. So if somebody else gets an idea about what it does and thinks, oh, this could be turned into a drug that would help people with cancer, they're going to have to pay a royalty to that original discoverer, which is going to be an impediment to going forward. So the whole thing gets turned on its head. And basically, in this instance, a patent, instead of being an incentive, becomes a disincentive. And that seems like a very unfortunate turn of events. So with regard to the system by which patents are decided, whether they're allowable or not, you have to decide, is this invention novel, is it non-obvious, and is it useful? And I think one could argue that a new DNA sequence that has not been described before is novel, and it's not obvious, but is it useful? And so a number of us, particularly Harold Varmus, when he was director of NIH, and myself, spent a lot of time beating on the Patent Office, saying that their utility standard was way too low, and they needed to raise the bar before granting patents on genes. People ought to say what this gene does, or describe a direct pathway about how you go from this gene to a product that you can defend. And if you don't even know, then you shouldn't be making this claim. We didn't get too far with that, although we did get them to raise the bar a bit, not as high as it should be. The other thing about a patent is, it's not just the patent, it's the claims. If you've discovered a gene, and you claim all possible uses of that gene, from diagnostic through therapeutics and everything else you can think of, you've really put a big fence around it. If, on the other hand, your claims are rather narrow, then you're not going to provide the disincentive for many other uses that I would otherwise worry about. Again, I think the big question is this a plan that is going to benefit the public if there's no product identifiable? And there's some more subtle questions about, do you ever need a patent in order to develop a gene discovery for diagnostic purposes? Because it's pretty simple, once you've discovered a gene variant that's associated with a risk of diabetes, to turn that into a diagnostic test. That doesn't require a big investment. Therapeutics, on the other hand, is a long pathway, may cost you hundreds of millions of dollars. You can kind of see patents for therapeutic purposes could in fact be beneficial to the public, or those therapeutics wouldn't get developed. So those are some of the issues that people have been debating about. I think the easiest way to kind of put this whole concept forward is to think about where in this road to discovery between basic science and a product do you actually want to impose a toll booth. Because a toll booth may be necessary if you want the road to be maintained and not to fall into disarray. And I think most of us looking at this scene over the last 15 years would say, that's okay, but let's put the toll booth up there where you're pretty close to the product, because that's the part where the road gets really expensive, and you want to be able to provide the kind of incentive to somebody to build a product the public needs. But unfortunately, in many instances, what we've done is to allow toll booths very early on in the discovery process, and that's discouraged people from traveling on the road because it gets too expensive. We have not solved these problems. There is like now a huge thicket of patents. Probably a third, maybe even more than a third of human genes have patents on them. We don't even know yet how many because the patent office takes so long to issue the patents, sometimes many years after they're filed. And if you're in a company especially and you have an idea about something that might be useful as a treatment, you have to decide whether it's worth your while to invest in a particular research pathway when it may take you 2 years and a lot of people with briefcases full of legal papers before you can even get started. And I know in many instances that has in fact discouraged good ideas from being pursued just because of the barriers that the patent presents. So NIH has taken the tack, and many other research institutions have as well, of arguing strenuously that these kinds of early stage basic science discoveries ought to be placed in the public domain. They ought to be freely available to anybody. And a very important decision of that sort that I think has really set the stage for a much more agreed upon attitude about immediate access without patents was actually a meeting that was held now 12 years ago by the people who were planning to sequence the human genome in this consortium I had the privilege of leading. This meeting, at the end of 2.5 days of intense scientific discussion, we pulled all of the major scientific leaders together without any real permission from their ministers of health or science to do so, and talked about this issue, about whether the human genome was going to be privatized, held back, or in other ways restricted as far as its access. And on the whiteboard in that particular meeting room, which happened to be in Bermuda of all places, John Sulston, who at the time was here in Cambridge, scribed for us the agreement that was made by that group of investigators. And just to point out, human genomic sequence generated by large-scale centers, automatic release of sequence assemblies greater than 1 kilobase, greater than 1,000 base pairs, preferably daily, immediate submissions of finished annotated sequence, aim to have all sequence freely available and in the public domain for both research and development in order to maximize its benefit to society. And that was unanimously approved by the roughly 30 people at that meeting. And that was a radical step. Because until that point, the idea of releasing this kind of sequence was something that you only did, if you did it at all, at the time of publication. So this was really quite a startling development. But I think it has begun to really filter out into many other applications where it is now considered, for this kind of basic information, the right thing to do. So all those discoveries I told you about genetics that are associated with common diseases like diabetes and heart disease, those are now also being deposited in the public domain immediately. You have some drumming in the background. Is that supposed to keep me moving? Okay. So again, I think it's a serious ethical issue. Do you keep data some way obstructed, or do you give it away? And I think the right answer is you give it away unless you can show how it is attached to a product that the public needs and investment is needed to make that happen. What about new genetic tests that are bursting out all over? I showed you those 2 websites earlier today about 23andMe and Navigenics, companies that are marketing all over the place for the opportunity for people to find out their risks. Should we just let that happen? Is that the market, let the market take over and see what goes? Or is there an ethical responsibility to try to be sure that this kind of information is not presented in a misleading way? Well, people will differ again in terms of their view on this. My own sense is that the laissez-faire approach, which is largely what's been going on so far, could ultimately get us in some trouble, in that people may embrace these kinds of information in ways that causes them to do things that are foolish as far as their own medical care. And as they maybe begin to realize that they've been snookered, there could very well be a backlash against the whole field that would slow us down from applying the more thoughtful kinds of approaches that are coming. U.S. News and World Report had a particular article on this in their cover story a bit ago. New do-it-yourself tests can show your risk of serious disease, but how good are they? Well, for the most part, not yet so good. You can go to Target, which is a big chain store in the United States, and either on-site or you can order it through the catalog. You can get a CATG, or a CATG, I guess they're calling it, a DNA storage and profile kit. And you can get your own DNA stored and profiled for somewhere between $29.99 and $99.99, depending on how much you want done on it. At Target, I mean, this is not what you call a medical establishment. So many concerns here, not a whole lot of action, a lot of debate. The governments seem to be bouncing back and forth between whether they want to get involved or whether they want to stay the heck away from this. But again, I think this is a serious ethical question. What's the responsibility of societies and governments to make sure that new developments that have medical implications are handled responsibly? What about access? I guess we don't worry so much about access to technologies where their value is still questionable, but once they start to get really valuable, what then? And this is, of course, not an issue that's limited to genetic technologies. This is really a question about access to medical benefits of all sorts. Certainly something that those of us who try to think beyond our own national boundaries quickly get uneasy and troubled by when you consider the massive differences that occur between access to technologies and resources to use them across the world. And I'm not sure I have an answer to that. I will say I've had the privilege of working several times in a small hospital in Nigeria. I'm just speaking to our two Nigerian friends about this. And in that hospital, while I didn't have access to the latest medical equipment or the drugs that had just been introduced 2 weeks before, I did have access to the kinds of medical treatments that had now gone out of patent and which were actually incredibly useful. And if that had not been possible, that is, if advances had not been made in other parts of the world that found their way to Africa, then things would have been much worse. So we shouldn't basically decry the fact that progress is being made somewhere in the world because it's not being made everywhere. As long as there is transfer, what we should do is to try to encourage that transfer to happen as quickly as possible. And I think there is a lot more attention now to this than there was maybe 10 or 15 years ago, but there's not nearly enough. Genetic technologies or genomic technologies are often assumed to be the last thing that would ever find its way into the less developed part of the world. But I'm not sure that's true. One of the projects that I'm most interested and most excited about right now in genomics is the sequencing of the malarial parasite, which has now been done for the major malarial organisms, but also for a variety of strains of each one. So you really have a chance to see not only what is a reference sequence, but what's the variability between different isolates, which begins to tell you which parts are constant that might make a decent vaccine, which you wouldn't know if you just have one particular isolate. And similarly, we've now got the sequence of the mosquito, and we are in the midst of sequencing a bunch of different mosquito strains, and of course we have a sequence of humans. So we have all three of the players in this diabolical malarial dance. And many people would see that as our best hope now for developing vaccines and drugs, which aren't going to help anybody in the United States very much, but could have a profound effect on the rest of the world. And that is, I think, one of the hopes that would come out of this study of this field, even though it sounds very high-tech, that some of the implications might extend well beyond the countries that are leading the high-tech revolution. What about human variation and our study of that, and how that affects the way we look at different groups with different ancestral origins? This is not a pretty story down through history in terms of the way in which biologists have classified different groups. You certainly heard last night a comment from Michael about Darwin's own slipping into that kind of prejudicial view. Does the study of the genome provide an opportunity to knock down some of those arguments? Or are we at risk of actually putting tools in the hands of demagogues who might use them in a way to increase the likelihood of prejudice? It's not an easy question to answer. So what do we know? It is now quite clear, with maybe a few people still arguing around the edges, but I think pretty much universally agreed to, that there was a single origin of Homo sapiens sapiens in Africa, somewhere in the neighborhood of 100,000 to 150,000 years ago. And these colored dots are supposed to represent the variation that was present in that founder pool, which we estimate based on a particular kind of population genetic analysis as probably constituting about 10,000 individuals. So that variation was there, and that's actually the major source of variation you find all around the world today. It was already there. There hasn't been a lot of new mutations rising up in that last 100,000 years, or at least not rising up to the point where it's present in very many people. Most of the variation that's common is variation that pre-existed in this founder pool. What has happened as people migrated out of Africa is that sometimes those were relatively small groups, and so the total amount of variation represented in the founder pool didn't necessarily go out with those who were leaving the continent. And so as you look now, as all of this is spread around the world, one can perceive that there are differences in frequencies of particular variants. First of all, there's more variation in Africa than anywhere else in the world. And that all makes total sense here because it was there and it has remained there. Although it's fair to say it hasn't stayed in one place, and anybody tries to model all this by assuming that Africans have stayed in one spot, they really don't understand the historical record. But what you see in Europe or in Asia is that, in fact, the amount of variation that found its way out of Africa is different. It's a subset. There's not as much. And in some instances, the frequency of a particular variant is significantly higher in that group or significantly lower. And some of that is just what we call drift, which is to say genetic variations don't stay at exactly the same frequency. If you have a small population, just by statistical fluctuations, they may go up or down. And some of it is on the basis of selection. And for me to just set selection occurring at this scale in just the past 40 or 50,000 years, I think would have raised a lot of eyebrows, and a lot of people would have challenged that until quite recently. Although if you think about it, we have one very dramatic example where selection has operated in the last 50 or 60,000 years. That's skin color. We were all once black Africans. As people migrated out of Africa, where dark skin is essential to prevent the kind of skin cancers that I saw in albinos in Nigeria, where having albinism in Nigeria is a death sentence because of the degree of UV exposure, which is invariably going to give rise to that kind of problem in a group of people who live outdoors. On the other hand, as humans migrated out of Africa and more into northern climates, it was not an advantage to have dark skin. In fact, it was a disadvantage, probably because of the whole problem of rickets and the need for sun exposure to be absorbed using that particular way, interacting with vitamin D in order to generate a pelvis that's capable of producing effective childbirth. And so there was a selective pressure, it seems, upon the system to result in lighter skin. And we have now identified a total of 3 specific genes in the human genome that are major contributors to skin color. This is not just hypothetical general conclusion. It's now nailed down at the molecular level, and I can tell you people with white skin are mutants. It's quite clear that in each instance, genes which in the African original population were involved in increasing pigmentation by providing melanin have been inactivated, resulting therefore in skin that is lighter. That, I guess, is an example which, by our current dating, shouldn't stretch back more than 40 or 50,000 years. You can look also at the example of the ability to drink milk as an adult, which became rather essential for particular cultures where milk was part of the adult diet in terms of agricultural practices of keeping cattle. And you will certainly see in those particular cultures that this variation in the lactase gene that allows it to be expressed at adulthood has almost reached 100%, whereas you find very few people in Africa who've not had that kind of culture where that's true. Interestingly, a very recent study in the Maasai, who also have milk as a significant part of their diet, shows that they also make a different version of that gene. But it's an independently arrived at evolutionary answer, so it's convergence at the molecular level, 2 different ways of keeping the lactase gene on in the Maasai versus the Northern Europeans. So that tells you that selection and evolution did not end 100,000 years ago. And in fact, in the recent analyses of the human genome variation efforts coming through that project called HapMap that I briefly told you about, there are probably at least 1,000 places in the human genome where there's statistically absolutely incontrovertible evidence that there has been selection in one of the 3 groups, Europe, Asia, or Africa, that were studied. You don't know what the selection was in most instances. You can just look at the genetics and say something swept through here that was beneficial, but you can't infer what it was. So what am I saying? I'm saying that even though we are descended from common ancestors quite recently, we are one big family, there are differences. And therefore, if I took a DNA sample from any one of you, and I had a sort of multiple choice about which ancestral geographic origin you represent, I could probably get your geography pretty darn close to right. In fact, you can buy tests, again, over the internet to infer where your parents came from, and it's based upon just this, that there is a difference in frequency of particular variants across the world, even though most of the variation was there in our founder pool. This is easy, therefore, to give you mixed messages, and it's very hard to say in one crisp sentence whether there's a biological basis for race or not. You see what I mean? I mean, basically, races, as defined in biology in general, do not fit here, because it's not as if there have been sharp dividing lines as humans have spread out over the globe, that you've sort of gotten out on a branch and stayed there. Our history is not that of a tree, it's of a wisteria vine, with lots of interactions in between. But it still says that when you get to somebody out here in one of these branches, you can make a pretty good inference about where a lot of their ancestry came from. This, of course, plays out most significantly in medicine in terms of the question of health disparities. When you see a circumstance where somebody has a higher frequency of a common illness, is that on the basis of genetics or is that on the basis of environment? And I think until fairly recently, a lot of people would have angrily said that genetics has nothing to do with this, that there's no such thing as race, and that basically the Genome Project has proven that to be the case. And some fairly silly comments were made in that regard by people who should have known better. But in fact, I think the issue is that we don't know in most instances whether a particular health disparity is on the basis of environment or genetics or both. And we need to figure that out if we're really serious about doing something about it. So you've got self-identified race or ethnicity up here. You've got health or disease down there. There's two pathways here, one being environmental exposures of lots of different sorts that may have a significant impact on that. But also ancestral geographic origins, which correlate pretty well with self-identified race. Genome variation correlates with ancestral geographic origins. That in turn correlates with specific disease genes that may have risk. And so at least in some instances, that's also a factor. And we also already now have some examples of that. So how can we, as benevolent individuals seeking benefits for all, take all of this that we're learning and use that in a way that is actually positive in this difficult question about race and its meaning? I think we're still struggling with that. And the scientists, I think, have a big responsibility to continually try to tell the facts of the story in a way that helps and doesn't hurt. Getting on to complicated and difficult issues. How will we react when genes are identified and really validated, not just sort of made up and turn out not to be true, that correlate with human behavior? We know they're there. If you look at the evidence from identical twins, I guess most dramatically identical twins that are separated at birth and raised in totally different environments, sometimes without even knowing they have an identical twin, and then you subject them to a measure of whatever it is you want to look at, whether it's a personality trait or an assessment of intelligence or whatever, you will find that there's a striking correlation. Not that it's like perfect, but something like half of many of the things that you measure on a personality test appear to be on the basis of inheritance. And if it's on the basis of inheritance, that means there are in there somewhere some specific genes, some specific gene variants that are driving that. As I told you, we have this dramatic success story going on right now in terms of discovering genes involved in common diseases, which are also pretty complicated, but it's working. And I can tell you, I know of 2 genes that are in press right now for human height, because you could very easily, with the same kinds of tools, if you've measured the height of all the people in your studies, you can figure out what genes are involved. In fact, I've heard there may be pretty soon a dozen such genes that are validated as being associated with the adult height that somebody achieves. Well, height maybe doesn't sound too scary, but other behavioral traits are likely to stir people up. We know they're there, but it's been hypothetical. When you actually can point to something and say, that's a gene that's associated with a particular anxiety trait or a novelty seeking, already there's some there that look pretty convincing, although not everybody completely buys them. How's that going to affect people? And most, perhaps, of explosive nature in terms of the kinds of things that people go around measuring a lot on individuals is intelligence. We know that intelligence has strong hereditary contribution, what we measure called H-squared, which is a measure of the hereditary contribution to a particular trait, is in the neighborhood of 40 to 50%. And there are going to be genes in there, and sometime in the next 2 or 3 years, they're going to get found. And I would be willing to bet that the version of a particular gene that raises the IQ by 0.5 points, and that's probably what these are all going to be, very tiny contributors. But I bet that none of those will have exactly the same frequency in different parts of the world. And so people will be quick to jump on that and say, aha, you see, I always thought that Asians were smarter, or whatever. And we should be very careful as those kinds of revelations come to the fore to look and see what actually is the impact of this factor. It's one thing to say that this T instead of that C is associated with your performance on an IQ test if you have 10,000 people to look at. It's another thing to say whether it's relevant at all to the individual. And it's very much another thing to say whether it has consequences for the fabric of our social behavior. But I can tell you, we're in for a pretty tough ride here, I think, as genetics finds its way into behavior. If intelligence is going to be controversial, wait for this one. There was a big fuss 14 years ago when Dean Hamer suggested that he identified an area on the X chromosome that carried some kind of a gene that was some kind of a contributor to the likelihood of male homosexuality. That turned out to be not something that could be validated by anybody else, and I think most people think that was a false positive result. But there are going to be results in there that are not false positives. It's quite clear, again, from the study of twins, that homosexuality has a hereditary component. It's not predetermined, it's not hardwired, but it is, in fact, uncontrovertibly the case that there are biological components in the genome that play some role in the likelihood, a predisposition, if you will. And they're going to get found. And this is, talk about a hot button in the U.S., particularly in the church. This is going to be a tough one for a lot of people, I think, to get their minds around. Criminality. Already there's a very interesting report coming out of New Zealand of a study of kids who had been abused as children and then ended up in trouble with the law as adults. And they looked at a fairly significant set of those kids, and they looked at a particular gene on the X chromosome called MAOA, monoamine oxidase type A. And they discovered that if you both had the particular version of MAOA that doesn't work so well, and you had childhood abuse, that your likelihood of ending up in serious criminal trouble was substantially increased. Whereas if you had just one or the other, it had no effect. So there's a gene-environment interaction, but in this case, what's being measured is criminality. And that looked like a very substantial study and has been, I gather, replicated at least one other place. How are we going to deal with that? How is that going to play out in terms of the court decisions about whether somebody is responsible or not for a particular action? I can just see the way in which defense lawyers are going to attach themselves to this and try to argue, therefore, that a particular person is not responsible for their actions. Now, in a way, there's a reductio ad absurdum you can attach to that argument, because in this room, I would guess that something like 2/3 of the people here have a variant that predisposes them to criminal actions that makes you about 16 times more likely than the other 1/3 to do so. That surprise you? Well, I'm talking about the males. You have a Y chromosome. That is the strongest risk for criminality that we're going to find. The statistics will prove that. And yet I don't know that I've heard somebody trying to defend robbing the local store on the basis of having a Y chromosome and getting off on that basis. So anything we discover subsequently is not going to be as strong as that one. So it gives me some hope that society can kind of get their minds around the idea that, yeah, you're dealt a set of cards, but it's still up to you to decide how to play the hand. And spirituality. Are there some of us that are predisposed to be interested in looking into the possibility of spiritual matters or believing in God? Is the reason that I'm a Christian and a scientist because of something in my DNA that may be susceptible to that? Well, again, if you look closely at aspects of personality tests, the people who do those would argue, yeah, there are some people who are more likely to be interested in something to do with the numinous. But it's a rather modest effect, to say the least. Perhaps we'll hear a bit more about this from Jeff Schlotz tomorrow, who's going to say something about it. And if you want to look at a truly ridiculous way of trying to argue for this particular example, it is Dean Hamer's book, The God Gene, which made it onto the cover of Time magazine, although it's never made it into a peer-reviewed journal. Dean basically took some data, which was actually not originally focused on spirituality at all, and drew a conclusion that maybe he'd identified a gene that correlated with interest in spiritual matters in a fashion that has never been reproduced, nor is likely to be. But again, don't be surprised if in the course of the next few years, people studying throughout the genome, looking at behavioral traits, come up with something which on a statistical basis seems to be a little more likely in churchgoers than in non-churchgoers. Again, that just says nothing about determinism. That says something about personalities are different. We have this big issue for many of these topics that I've been mentioning about whether we have a public and healthcare providers that are ready to help us negotiate through all these dilemmas. And we clearly do not. And this is a major educational challenge in all parts of the world. And certainly in the U.S., we're not making much progress. One of the things we're trying to do in terms of helping the public get more tuned into the medical implications of this is to provide a free website that allows people to collect their own family medical history, which is, after all, a genetic test, and it's free, and it's pretty reliable, and yet it's not very well used. And this is now being utilized by hundreds of thousands of people, maybe in a way to begin to think about genetics and how it might affect your health care as a sort of foot in the door. And we also have an organization, the National Coalition for Health Professional Education and Genetics, which now has an international arm that's trying to get health professionals up to speed, given that most of them have had zero education in this field of genetics during their medical school training. But we have a long way to go. And we should be obviously doing this in the schools, and yet the schools are still edgy about talking about genetics because that's connected to evolution. And you know what that's going to lead to when the PTA meeting gets going, especially if you're in the South. Number two, we're getting close. When we arrive at consensus, here's a tough one though, about the limits of genetic technology for trait enhancement. I think most of us celebrate the opportunities that genetics presents us with in terms of curing terrible diseases. But what about trying to make ourselves just a little better than we were actually born to be? And this is easy to sort of quickly be against. But I think we got to talk a minute about what enhancement really means and whether it's something that we are already doing in other ways, and therefore ought to be a little bit more thoughtful about where our boundaries are. If you want to see an example of genomics gone crazy in terms of enhancement, go and watch the DVDs of this movie, which are still available, although the movie didn't do very well when it first came out. So this portrays a society where everybody gave up all of their civil rights and decided to worship at the altar of deterministic genetics. And basically everyone is tracked from the moment of birth into a particular life plan. Of course, the movie proves the premise to be wrong by the fact that the hero, who somehow escaped that kind of genetic tuning, turns out to be capable of doing almost anything he wants to, and all the perfect people are killing each other and smoking and drinking and other things. So it's actually, the message is the right one, even though the story is a bit odd and contrived. Well, what is enhancement? Hard to come up with a definition. This is, I guess, one that I think gets about as close as what I've seen. An intervention designed to improve human form or functioning beyond what is necessary to sustain or restore good health. Okay, with that definition, are you and I already enhanced? Well, you bet we are. In the genetic terms, though, the kinds of enhancement that people are talking about and worrying about can be broken down into certain categories. There's somatic enhancement, which doesn't affect your kids, just you, which could be genetic or non-genetic. It could be biological, or it could be environmental. I'll give you some examples in a minute. The thing that people, I think, though, are most talking about when they are worrying about enhancement is the kind that will actually affect the germline. It will affect your children and their children and so on. And there are ways in which this can be done already. And there are ways that are hypothetical that are probably not going to be ethical for a long time. And I think it's helpful to make the distinction between them. So let's go to that. Germline manipulation or directed genetic change. Again, we routinely do this in experimental animals. My lab and many others are routinely altering the mouse germline to see what will happen if you knock out a particular gene or if you overexpress it. It's a very powerful way to understand biology. But in humans, I think safety considerations alone would rule this out. in any applications that I can think of, because you would not know, and potentially might not know for a couple of generations, if you had done a harm. By manipulating the genome, who could say they're absolutely confident of the results of that manipulation? Until we get to the point where you could go in and change a single letter of the code and leave no footprint behind, this is going to be, I think, off the table as far as ethical experimentation. And we're a long way from knowing how to do such a precise surgical change in the germline. And furthermore, it's difficult to come up with scenarios where, for medical purposes, it would be reasonable to do this anyway. In enhancement situations, they're more imaginable, where you might want to go in and sort of tweak that gene, especially if you've discovered a variant that's associated with intelligence, for instance, and offer that yuppie couple a chance to have a kid that's a little closer to what they think they want. And I think that really does cause the hair to start to stand up on the back of your neck. So are we able to do that kind of germline manipulation? Well, again, we can do that in the mouse. We can either insert something, or we can alter what's there, knocking it out or changing its expression by homologous recombination, that is, changing it right in situ in the chromosome. And an area that has been developing, albeit somewhat slowly, but which I think is worth paying attention to, is that you could actually engineer a completely artificial chromosome, where you wouldn't have to go in and tinker with the chromosomes that are already there. You provide a whole new vector. So how do you do that? Well, basically, you need to have the appropriate mechanics to have that piece of DNA be self-replicating and stable, which means you need a centromere and you need telomeres. But then you would throw in your favorite target gene. You could even throw in a sort of suicide gene that you could use to select against this if something started to go wrong. And that's been a proposal that's been on the table. And if you could then take this kind of artificial chromosome, put it into a cell, then every time the cell divides, this should divide too. And you haven't actually mucked up the chromosomes that were already there, so this might have a heightened appeal as far as safety. Well, some of this has been done, and this is in a cell culture. I'll be quick to tell you, this is not in a person who's walking around, but in cell culture, here's an example. This teeny little thing here is one of those human artificial chromosomes. These are the normal chromosomes, obviously much bigger. And people have made some headway with doing this, and I suspect that if we do get to the point, a long time from now, of contemplating actually trying to change human biology in the germline, that people would advocate for doing it this way. Again, because you're not messing up the chromosomes that are already there, and maybe if things go wrong, you can just get rid of it. But that still seems like a very major leap to most of us. Now, the other way in which the germline is altered, not by specific intentional change, but by skewing the odds towards what kind of embryo a particular couple is able to generate, is pre-implantation genetic diagnosis. This is the circumstance where you carry out in vitro fertilization, and then on those 8-cell embryos that you allow to develop after fertilization, you pluck out one cell, leaving 7 behind, but all of those 8 cells are identical genetically. You can do a DNA diagnosis with a single cell. You can then determine what is the genotype of each one of those embryos, and you can decide which ones you're going to reimplant and which ones you're not. And this is actually building rather rapidly as a capability in many places, and it's essentially unregulated, which is a little scary. And some 10,000 cases at least have been done for various purposes, chromosome problems or Mendelian conditions like, say, Tay-Sachs disease, where you know that the outcome is going to be a very severe one if an affected embryo is reimplanted. And couples are flocking to do this to avoid the experience of amniocentesis and pregnancy termination, which is their other alternative. And yet this is a circumstance where you are generating a fertilized embryo. This is how it's done. This is a holding pipette. This is an 8-celled embryo. This is the aspirating pipette that has just plucked off one of the cells, and that will then be subjected to this kind of DNA diagnosis. And again, as I said, you can then decide which ones to transfer based upon the outcome. Well, in fact, the Gattaca film that I mentioned uses exactly this scenario in a rather chilling and realistic scene where the genetic counselor showing the couple a whole bunch of embryos on the screen says, well, we've now diagnosed these, and this one right here is the best that you could be. You could try 1,000 times to have a child the natural way, and you never get one as good as this. So basically, you can skew the odds in your favor. Now, there's a real problem with this if you're talking about skewing the odds in the favor of the kinds of things that I think hard-driving couples with lots of resources would want. They want the kid who, you know, plays the football on the first team, the kid who plays first violin in the orchestra, and also gets A+ in math. And trying to put all those things together when each one of those is contributed to by dozens of different genes, each one of which has a small effect and a huge environmental consequence, they're likely to be very disappointed at the end of all this, having paid out tens of thousands of dollars for their pre-implantation genetic diagnosis when there were only about a dozen embryos to pick from, so you couldn't very well optimize for all of these different genes. They end up with a kid who's, you know, kind of up in his room, listening to heavy metal music and smoking pot. Because they forgot about the fact they had to actually be parents and give this kid something in the way of a childhood experience. So I'm not so worried that in the application of this to traits, enhancements, that we're going to see wide application. It just isn't going to work very well. Even though it may be morally offensive, and I think it is, it probably won't get very far because it isn't going to work. Well, let me finish up this enhancement discussion, and I'm almost done, Dennis. Basically trying to help us think through what should we be worried about and what is just either already happening and acceptable or just not going to happen. And I've made up this axis here where we have level of concern over here from admirable to unacceptable. Yes, there are going to be some admirable enhancements on my list. And then the timetable to when they're going to happen. And I think I would argue that the things we should worry about are down here in the lower right quadrant, where they are questionable or unacceptable, and they're actually feasible in a measurable period of time. That's where we should pay attention. And a lot of the things that are currently being bandied about don't actually land there. So let's see what we get. Okay, hair coloring. Where should we put that? Well, I guess most people would say it's acceptable. I'm sure there's probably somebody here who colors their hair. I've thought about it. And I think about it more every year. Music lessons. Doggone it, that's an enhancement. It brings out something that otherwise might not happen, and we don't think of that as in any way questionable. That's admirable. Cosmetic surgery is definitely an enhancement, but maybe a little closer to the questionable side of things. Exercise. You know, that's an enhancement too, and we're all promoting it, and we should be. Fluoridated water, that's enhancing your tooth strength, and that's acceptable in most places, even maybe admirable. Immunizations, probably the best example I can think of a biological enhancement. That is changing your DNA. When you get immunized against a particular virus, you are taking some of your immune cells and you are rearranging their immunoglobulin and T cell loci in order to make an antibody response or a T cell response against that, and that has changed your biology. And yet we're pretty comfortable with that. In fact, that's the admirable category. So don't let anybody try to tell you biological enhancements ought to be off the table. Otherwise, we're all in trouble. Prayer. I don't mean to be funny about it, but I think prayer is in the admirable category, and perhaps is an enhancement in the sense it enhances our sense of relationship to God.
Can you say it can be done now?
Yeah, right now.
By the genetic recombination?
No. Not all of these are genetic. Let me be clear about this. These are just enhancements. Some of them are biological. Some of them are not biological at all. But they enhance the individual in some way or another. Viagra. Well, okay. I guess some people would call that acceptable, and I gather some find it to be an enhancement as well. Ritalin for kids who have behavioral problems, getting a little closer to the questionable zone here. Mood-altering drugs, certainly more questionable. Recreational drugs, now we're getting over to the zone of concern. I think we'd all say they belong there. Again, that's not a genetic enhancement, but it is an enhancement of mental circumstances. What about using human growth hormone for normal kids who have normal stature, but their parents just want them to be a little taller so that they'll be more competitive or more attractive? I think that's considered by most people as unacceptable, even though it's acceptable for treating certain forms of genetic dwarfism. Using erythropoietin for athletes, doping, the things that's getting all the bikers in trouble. Again, society strongly feels that that's unacceptable. Sex selection. You know, that's going on right now, but not just by in vitro fertilization and pre-implantation genetic diagnosis, but even using chorionic villus sampling or amniocentesis and terminating the pregnancy if the couple says that's not the sex we want. So I'm putting it in the unacceptable area, but many geneticists now are willing to participate in that kind of action. Something called IGF-1, a very powerful gene that makes a powerful protein that seems to slow down the aging process. I used to think this was unacceptable, and now I'm maybe changing it. Moving it into the questionable zone now. But this is something we're going to have to deal with in society, as to what extent do we think treatments that slow down the aging process are actually something that we should be supporting and maybe even paying for. On the other hand, this same IGF-1 is clearly going to be an enhancement for athletes if it's figured out how to use it, because it builds muscular strength. And in that category, I think we'd say no. Individualized preventive medicine, if we get there, based upon all of these discoveries in the genome, well, that's going to be an enhancement, and I think that's a good thing. Jumping over to PGD, for Tay-Sachs disease, a disease that will kill a child within their first 2 years of life, and a miserable 2 years it would be. I think a lot of people would call that an acceptable intervention, not everybody. But if you're talking about PGD for an adult onset condition, like breast cancer, the BRCA1 gene, questionable but now allowed in the UK by the authority. PGD for obesity. Just don't want to have a kid who's overweight. That's starting to get pretty uncomfortable, so I'm pushing that over a bit. And intelligence. I hope we don't go there. Again, it's not going to work very well, but I think it would be unfortunate to use it at all. Skin color, likewise. Drugs that keep normal people thin. Well, that sounds better than it used to also. Human artificial chromosome transfer to embryos in humans. Again, the ethical risks are so huge. And now we're getting up into the area of 100 years from now, as far as feasibility. Never forget anything, never sleep. I could use that, couldn't you? We might figure that out. But still, I think a little hard to figure out where that would fit on the ethical scale. So there we are, and you can sort of see a bunch of things have ended up over here. I'm not sure you can remember what they are, but I would argue that those are the places we should be paying attention and enhancements, and not worrying quite so much about things that are either too far away or actually are already commonplace. Oh, an extension of the lifespan for 200 years. Again, maybe we'll figure out how to do that. So finally, and this sort of sums up a lot of the philosophical discussions that people have been having and should continue to have, is will all of this knowledge about the genome cause us to succumb to this view of genetics as deterministic and cause us to neglect the role of the environment, the power of the human spirit, and our need for God? A terribly unfortunate outcome for those of us who see genetics as a way of getting a glimpse of God's mind. And I've showed you that already as something that we need to keep in mind. So how should believers view the genome era based on all this? I think recognizing the mandate to heal, we should, on an ethical basis, feel very comfortable encouraging the advances that reduce human suffering. Christ, in the very short period of time he was on this earth, spent a lot of his time healing people, and I think we were supposed to notice that. And that's true of virtually all of the major or world religious traditions. But, recognizing our moral responsibility, we should work to make sure these advances are not misused. And I like this cartoon, otherwise we're going to be having to answer to this guy. But now, some will say, are only believers those who have a moral compass that is anchored enough to participate in those decisions about what the right pathway ought to be for use of this information? Well, ironically, I think the moral law comes to our rescue here. Because I argued in the previous talk that the moral law is a universal human attribute. And the moral law, in many ways, therefore, is something that we all recognize, we all share, whether or not we're believers, and becomes the foundation, after all, of bioethics. And so, because this is a God-given feature of all human beings, whether or not they believe in the source, then we shouldn't be surprised if, in fact, secular and religious ethicists are often, not always, able to reach consensus. And I think, in fact, that has happened most of the time for many of these dilemmas, but not all of them. Finally, all of these various points require believers to be well informed. The times I have seen these discussions about bioethics run most severely off the tracks is when it was not clear that the people who were trying to debate the right and wrong understood exactly what the scientific opportunities were and were not. And this brings, in my final slide, us back to Proverbs 19:2. It is not good to have zeal without knowledge. That's true for a scientist, and that's true for a non-scientist. So I'll stop there, and I'll be glad to answer questions from all of you. Thank you very much.
Thank you very much. Well, I'm sure that's triggered a host of questions.
So I was wondering if there is any effort to look at the environment which brings about genetically determined behaviors. Is there an attempt to get a correlation there?
I think we'd like to if we had better ideas about how to do that. I mentioned the one example, although it's a fairly sobering one, about child abuse combining with a particular genetic variation, correlating them with adult criminality. So that's certainly an environment-gene interaction. And as we get, I think, a better handle on what the variations are in the genome that associate with particular personality traits, then we might be able to see to what extent environmental exposures enhance that or not. I saw another study about depression that was interesting in this regard. So there is a variation in a gene that's involved in dopamine metabolism that's been implicated in susceptibility to depression. And what they were able to show is that the people who had had major life stresses and also had the genetic susceptibility had a higher likelihood of getting into major clinical depression than people who had only one of those two things. That the people who didn't have the genetic susceptibility had a major life stress, were able to bounce back from it. The people who had the genetic susceptibility but hadn't had a major life stress were no more depressed than the other folks. But you put the two together and people ended up in trouble. It's that kind of thing that I think we'll see a lot more of. But again, it sort of helps if you've already made some progress on the genetic front in order to be able to know then what to look at in the environmental circumstance. They go hand in hand.
Yes, question over here.
Hello, sir. I've heard people supporting the idea that one day through, for instance, gene therapy, some genes involved with particular illnesses could be treated as viruses or like the smallpox and eliminated from the human populations. And when we think that many illnesses, and especially mental disorders, are associated with creativity and artistic skills, wouldn't we? Isn't there a risk that we will lose these abilities if?
Sure. No, that's a great point. If you look, I don't know how many of you read books by Kay Jamison, who's a psychiatrist who's written a lot about the correlation between creativity and particularly bipolar illness, manic depressive disease, and has a really startling documentation based on extensive research that more than a third of the artists and poets that we all think of as the most creative contributors to Western culture are diagnosable manic depressives and did most of their creative work during periods of mania, and then many of them killed themselves in periods of depression. And certainly, if we were to come up with a way of eliminating that disease, there would be serious consequences to many of the things that we most admire as examples of human creativity and beauty. So one needs to be thoughtful about that. I don't think at the genetic level there's much risk of that because those disorders are turning out to be pretty complicated genetically. It's not that there is a gene for manic depressive illness or schizophrenia or attention deficit hyperactivity disorder or a number of these other conditions like obsessive compulsive disorder. It's going to be very complicated, multiple different variants that contribute to this, many of which are common, so you can't very well go in and just wipe them out. So I think the actual likelihood of changing the gene pool for humans in the next many decades is going to be quite remote. It would only be possible, again, because I don't think we're going to be in a position of manipulating the germline. The only way you could change the gene pool is by some kind of selective reproduction, maybe using PGD, where you try to stop reimplanting embryos that have a particular genotype. But for conditions like the ones we're talking about, that's just going to be so completely ineffective in making anything more than the tiniest difference in gene frequencies that I don't think you're going to see an effect. And what that says is, by the way, is all this study of the genome is going to be really interesting as far as understanding risks of health and disease. But if you want to help people get healthier as a result, it's going to be by changing their environment and their medical care, not by changing their genes. What you have is what we're going to have for a long time.
I think, Ron, I can see how he runs, and then we'll come around.
If I was listening carefully enough, I didn't hear you ever use the word eugenics. And I was wondering if it's because you think that what's going on today is fundamentally different from eugenics, or if the word is so pejorative now that you and your colleagues go out of your way to avoid using that word?
I think it's both, and I appreciate your pointing this out. Yeah, eugenics, in your description this morning, which was very illuminating about sort of the history of what's happened in the 20th century. One aspect of that history, which is very troubling and remains so to geneticists, is the role that geneticists played, particularly people like Davenport, in this country, in promoting the idea that it would be possible by selective sterilization to be able to change the gene pool and to get rid of genotypes that were undesirable, and that led to tens of thousands of sterilizations occurring in most states across the country in a way that, in retrospect, is really very hard to justify. In fact, it's one of the sorrier chapters in the application of science to society. And I think the genetics community still carries such a weight of guilt and responsibility for having been part of that, that it is hard to say the word eugenics in this kind of a presentation. But you're right to point out that it's in there just the same. The discussion I gave about genetics and race, I think clearly one of the concerns will be is that we learn about variation and how it's unequally distributed amongst races, and that could give rise to a new eugenics, where people will say, well, you see, here's the biological evidence that these people from this geographic region have this particular genotype, and therefore they're not as good as I am. And you can just see that starting to emerge in some of the sects that have the greatest agenda here to try to promote that. And similarly with pre-implantation genetic diagnosis, this is not what you'd call a state-sponsored eugenics. This is a homemade eugenics. And it's something which nobody's really doing anything about, and it's an unregulated industry. But at the present time, it's sort of on that pathway where well-heeled couples may take advantage of not terribly adequate or accurate technologies, but they may do it anyway to select sex, to perhaps begin to try to select traits that they like or don't like. And that is eugenics, isn't it? Not in the full-scale Nazi Germany version, but it's the same mentality. And I think it is a mentality that geneticists, for at least another several hundred years, are going to be very worried about.
There's a question back here then. Yes.
There seemed to be a little light of breathing space in the political process by the fact that the juggernaut moves slowly, which gives us a little bit of time to think. On the other hand, what do you perceive to be the risk of companies and researchers going to places outside of the Western democratic process, doing things in a chaotic, uncontrolled and free-for-all manner?
I think that risk is always there, and I think it was of some reassurance, but maybe you could argue doesn't have a lot of clout, that actually now some 10 years ago, UNESCO put together a statement on the human genome and human rights that was signed by all the UNESCO participants. It's a very good statement. It goes on for 28 articles, and it has lots of the components of the bioethics agenda that I've gone through with you this afternoon. Interestingly, the U.S. is not a party to UNESCO, so we didn't get to sign it, even though we helped write it. It was then signed by the UN General Assembly as well, so that carried additional clout. But of course, we all know that if a particular renegade country desires to ignore that, there's not a lot of teeth to such resolutions. At least, though, there is a shared sense that this is a set of principles that needs to be adopted essentially worldwide, or it isn't going to do any good. That the world is flat, and that all kinds of technology opportunities are going to exist in lots of places. I guess right now the place where this is most clear is the area I said I wasn't going to talk about in the initial presentation, which is stem cells, where with such steep restrictions on stem cell research in the United States, not only the research, but some of the researchers have moved elsewhere in order to conduct that kind of research. Now, some people would say that's an example of this kind of renegade behavior. Other people would say that's an example of trying to keep science going, even in a circumstance where some parts of the world have an unnecessarily restrictive attitude.
They did come to Cambridge.
They came to Cambridge, that's right. They're all right here, right? Probably in this room. How's it going?
Yeah, I think, yes, the question.
I have a 6-month-old baby, and when it was born, I was surprised that in the Netherlands something had changed, because now babies are routinely diagnosed on no less than 20 different hereditary diseases.
Yeah.
And what was also surprising, that now we had to tick a box whether we wanted to be informed in the case we would be carriers of recessive alleles, possibly to be used in view of future family planning, so that we could abstain from further kids or go into that pre-implantation diagnostics as an alternative. And irrespective of the question whether that is a desirable or a non-desirable development, it showed to me that for the lady coming, she is now going to be a genetic counselor to dozens of uninformed families, and I think it's creating a kind of influence into a society where perhaps people born with disabilities are looked upon as, did those parents didn't take care of their genetic records? And I think while trying to help people with genetic counseling, in fact you make less place for people with genetic afflictions. Could you comment on that?
Yeah, I think that's a very important point, and probably one that I should have added to my list, because it is a great cause of concern in the disability community. You can see this one both ways. If we have the ability to diagnose children who have particularly conditions where early diagnosis is the mainstay for effective treatment, and the classic example is PKU, phenylketonuria, where kids with that disorder, if not immediately recognized at birth, end up with severe retardation and seizures, and end up in lifelong institutional care, whereas if recognized and put on the appropriate diet, they grow up entirely normal. That's been the initial motivator. But as we've gotten better and better at discovering a longer and longer list of rare diseases, it has seemed to be similarly an ethical mandate to screen kids to see whether they have them in order to apply this kind of intervention. But the list is beginning to add things that are not like PKU. Certainly, many of these conditions now are compatible with long survival. Cystic fibrosis is in there on many of these newborn screening programs. And most kids with CF don't get diagnosed until they're maybe a year or two old, but the average survival now is age 36. So it's a bit different. And of course, that is a circumstance where their parents must be carriers if the child is affected, or even if the child is a carrier, one of the parents is too. So you're starting to bring other family members into this. And you might argue that this is a way for society to begin to come to grips with genetic issues and begin to incorporate them into their thinking, or you might argue that this is actually just scaring a lot of people with information that they would just as soon not know about. I think, though, you're putting your finger on that part of this that is the most troubling, which is the implication that such programs have is that basically the goal is perfection. And that's what we're trying to achieve here. And if somebody in the society doesn't seem to have achieved perfection, well, something went wrong. And I've had many conversations with people with genetic disabilities who are deeply troubled about this. Are they trying to basically make us go away? Are they trying to say we're not needed anymore? Are they trying to say we're not really acceptable parts of society? We're a bother. We're the kinds of people that we really, that the rest of society thinks should have been gotten rid of. I don't know how to resolve this. And I think a lot of it really has to be very sensitive explanations about what are the points of these screening programs. My view is we shouldn't be screening newborns for a condition for which no intervention is necessary in the early part of life, because otherwise you are giving information of no immediate value, and you're stirring people up, and you're not necessarily helping them, and you are, in addition, carrying this consequence of potentially implying that disabled individuals are somehow lower in society than the rest. And that's the problem is the technology is now getting so good that people are just adding more and more tests, and we now have this thing called tandem mass spec, where you basically take a blood sample and you screen for dozens of disorders, many of which you don't know whether an intervention is going to work or not because it's never really been tested. So the information is growing about what's there without it being attached to an action that's necessarily benevolent. And that is, I think, a cause for concern. That's a great question.
Thank you. I think there's going to be a lot more questions. I think we are going to have a break, but remember, there's the opportunity to put your questions in the box at the back in the comfort break we're about to have. First, before we do that, I think we want to thank Professor Dr. Collins again very much indeed for a fantastic presentation.